Moving on to the next question. A particle starts from rest and travels a distance of 10 meters under constant acceleration, then travels a distance of 30 meters with constant velocity and decelerates at a constant rate and travels another 5 meters to come to rest. If the total time of travel is 30 seconds, find the maximum velocity attained by the particle. So the total travel has 3 segments. First part has 10 meters, second part, which is uniform motion, has 30 meters, and the third part is decelerated motion, it has 5. It is better to use the graphical method to solve this question. Okay, so let us draw velocity time graph here. Velocity is taken on y-axis and time is taken on x-axis. Initially, there is an accelerated motion for which the graph is a straight line with positive slope. Velocity keeps increasing as it is an accelerated motion, right? Then there is uniform motion. That means the graph has to be horizontal. For a uniform motion, velocity is constant. So the graph has to be a horizontal straight line. And in the end, the particle decelerates and comes to rest at a constant, and this is done at a constant deceleration. And if I take the area under the graph, this is velocity time graph. Area of velocity time graph is nothing but displacement of the particle. It is given that the displacement in the first segment is 10 meters, second segment is 30 meters, and the third one is 5 meters. The question is to find out maximum velocity attained by the particle. And we have to take a particular thing here. We have a square and I'm drawing a diagonal over here. And if you look at this, on either side of the diagonal, the area will be the same. Or this area, if this area is 10, this area also has to be 10. Because when I draw the diagonal, the area is equally split up. So my point here is, if I have this area as 10, I can construct a triangle here, so that this area is also 10. Similar way, I'll construct a little triangle here so that its area is also 5. Because this looks like a square now. If this area is 10, which is given in the question, on the other side of the diagonal, the area has to be 10. Similar way, here the area is given as 5. So that area also has to be 5. This area has to be 5. Okay, right. So now the whole thing looks like a triangle now. And if you look at it, this is nothing but the maximum velocity of the particle. Why? Because initially there is an acceleration for the particle. It keeps accelerating and it attains a maximum velocity over here. Thereafter, it is uniform motion. So this velocity corresponds to maximum velocity of the particle. And it is also given that the total time, that is t1 for the first part, okay, t2 for the second part, and t3 for the third part. If you add them up together, what you're going to get is 30 seconds, because the total time taken is given as 30 seconds. And if you take this rectangle, the total area of the rectangle is given by what? Total area of the rectangle is length into breadth. Length is 30, total time 30, into breadth or height here is V max, maximum velocity. I can replace the area here. What is the total area? 10 plus 10 is 20 here. 20 plus 30 is 50. 50 plus 5 is 55. 55 plus 5 is 60. So I can find the area of the whole of the big rectangle here and I can put it over here. It is 60 is equal to 30 times V max. And if I cut 0, 0 on either side and take 3 to left hand side, 6 by 3 is equal to V max. So I'll get V max value as 6 by 3 is 2 meters per second.